Welcome to episode number 10, where we will discuss why we use 4 to 20 milliamps in industry instead of voltage signal. So let's get started. The physical signal, such as a temperature, comes from the physical system itself in the field. For example, 0 to 10 bar or temperature signal into a sensor. It gives an electrical signal or a resistance, and then a transmitter converts this signal here to 4 to 20 milliamps or 0 to 10 volts or any other electrical signal to the PLC or DCS. But how can the microcontroller or PLC read the current signal? Now, electronics use analog to digital converters to convert voltage signals to digital numbers, which are understandable by the CPU. Now, as for current signals, they are converted to voltage signals like this. This is the measuring device. It has a 250 ohms resistor. Now, when a 4 milliamps times 250 ohms equals 1 volt, and 20 milliamps times 250 ohms equals 5 volts. And this one goes to the analog to digital converter for conversion. Now, why do we use the 4 to 20 milliamp current signal instead of voltage? The main reasons are: first, drop voltage. For very long cables, which are the standard in industry or any plant, these have resistances in them, and this will make a drop voltage in the wire. Now, before the signal goes into the measuring device, it will be changed. However, currents do not have this issue. Electromagnetic interference, we know that currents are more robust against the noise comes from them. Now, can detect open circuit. Now, if you consider 0 volts or ground to be the minimum reading, you cannot determine if you actually read 0% from your sensor or actually the wire is cut or open circuit. And this is why 4 milliamps is the minimum. Thus, 0 milliamps will mean an open circuit. Now, let's go to circuit simulation and see what we have talked about. This is 5 volts, goes into the measuring device. It is 250 ohms, and it is 5 volts. However, if we add a wire resistance right here of say 10 ohms, and we try to simulate again, now 5 volts comes from the transmitter, and it reaches the measuring device at 4.8 volts. Thus, we have lost accuracy. While if you consider this current signal right here, this is a 20 milliamp current, and it is converted to 5 volts because it passes through the 250 ohms. Doing the exact same method right here, this is the long wire resistance. Simulate it again. This is here is 5.2 volts, and we have converted it to 5 volts. So the transmitter power source could actually compensate for any drop voltage that happens along the wire. And thank you for watching.